Alright, so this video is going to be on a little bit of stats help before the Chapter 5 quiz. Some of you have expressed concern about it and whatnot, and like I said, I'm not a completely heartless person, only a mostly heartless person. So hopefully this will help alleviate some issues for you, because like I said, at the moment this is the only tool I have available at this point in time. So here we go. Again, this test is basically divided into three parts. We have the non-designated probability distribution. So this right here, it's not binomial, it's not Poisson, it's just a probability distribution that we have a table for, and that's it. And then we have a binomial and a Poisson later on down the road here. So let's check out this one first. So we have a weighted die. That's why the probability of it. So the chance of getting a 1 is 35%. The chance of getting a 2 is 25%, as they tell us, and so on and so forth. First things first, again, in a probability distribution, no probability should be negative. None of them are. No probability should be above 1. None of them are. And they all should add to 1. They all do. Feel free to check if you want. So what's the average of this probability distribution? Okay, well, to get the average, we're going to simply take all our outcomes, take all our probabilities, multiply them together, and then add them up. Now, we could do that by hand because it's a small enough table, or we can put them into our calculator. So, stat, edit. Here we're going to type in 1, 2, 3, 4, 5, 6. Then over here we have 0.35, 0.25, 0.1, 0.15, 0.1, 0.05. Once we have them all entered in, then we're going to go to second vars, which is the distribution menu. Oh, wait, sorry, my bad. Second stat, which is the list menu. Sorry, I got stuck in my throat here. Oh, what the heck was? Second stat, we're going to go to our list menu. We're going to go over to math. Going to go down to where it says sum. Boom. We're going to say L1 times L2, and we get an average of 2.55. So on average, we're going to roll 2.55. Now, can we roll 0.55? No, but again, it's an average, so that's fine. What is the standard derivation? So the standard deviation, sorry, is similar to the average, except it starts with an L1 squared. So we go second L1 squared. There you go, squared. So we do that minus the square of our average. So in this case, 2.55 squared. So same way, just L1 squared instead of L1 minus average squared, and then square root that answer. Make sure you don't forget the square root part. And we get 1.56. Okay. Now, if I wanted to figure out what the unusual values would be, I would do 2.55 plus 2 of these and 2.55 minus 2 of these. That would give me my boundaries for usual and unusual in case I ask. Now, this part here, again, is a little bit old school, so I might have forgotten about this. What is the probability of rolling less than a 3? Okay, well, you might be thinking, well, don't I need the binomial or Poisson? You don't if you have the table. The probability of rolling less than a 3. Well, less than 3 means 2 or 1. Well, the probability of rolling 2 is 0.25. The probability of rolling 1 is 0.35. So if I add those together, assuming I do my mental math right, I get 0.6. And that's my answer. So I don't need a PDF or CDF here because once again, I have the table presented to me. I can just add them up myself. Same with this one down here, 4 or more. Now be careful here. 4 or more this is going to sound weird, is 4 or more? Well, yeah, 4 does fit that description. 4 is 4 or more. So I want to include 4 and then everything more than it, so 5 and 6. So I do 0.15 plus 0.10 plus 0.05, and lo and behold, I get zero point 0.3. Okay? So if I have the table given to me, I don't need to rely on PDF or CDF. I can just go with the table and manipulate the probabilities as I want. So if I want the probability of rolling a 2 or a 4 or a 6, I can just add up 2, 4, and 6 together as they are. No need to worry about any sort of combination of PDF, CDF, stuff like that. So that's how you do it if you're given a table and it's not Poisson, it's not binomial, it's just a normal probability distribution. If it's this case here, it says in a certain brand of popcorn, each kernel has an 80% chance to pop. When it's microwaved, the bag has 250 kernels, and then it asks you to figure out the probability of a certain amount of kernels being popped. So this is a binomial because each kernel is like a trial, right? So we have 250 trials in here. And it wants to know what's the average number of kernels that would be popped. Now again, people tend to freak out about this question, but this is a very basic question. If I told you that there are 250 kernels in a bag, and you're going to expect 80% of them to be popped, how many kernels should be popped? Well, it's just going to be 250, or n, times 0.8, or p. Remember, this is my p, my chance of success. This is my n, my number of trials. So it'd just be 250 times 0.8 250 times 0.8, and we get 200. So we would expect about 200 kernels to be popped on average. So 10,000 bags checked, we get about 200 of them being popped out of 250. The standard deviation. Now again, we don't have a table to do standard deviation like we do here. So you might be asking yourself, well, how the heck do I do a standard deviation if I don't have a table? Do I have to do like 250 different things? Well, no, because in a binomial, you have the shortcut. The standard deviation for a binomial is root NPQ. So in this case, it'd be root of 200 times 0.8 times 0.2. And so if we do that here, 200 times 0.8 times 0.2, and we square root that, and we get 5.66 if we round that 5 up. So 5.66. So again, for a binomial, you have the shortcut to do standard deviation because binomials are special. Right? They're not like a normal probability distribution. That's why they have their whole little subgroup. What's the probability that 200 kernels will be popped? So we want exactly 200, right? Exactly 200 kernels. So that's going to be a PDF thing. So we're going to do binomial PDF. The n goes first, 200. The p goes second. We have an 80% chance of being popped. Again, 80% chance of success. And then how many kernels do we want popped? Well, I made a mistake here. Caught myself. Some of you might be screaming at me right now, which is good because that means you know what's up. We want n first, which is 250. So we have 250 kernels total to be popped. 80% of them are likely to be popped. We want to check what's the probability that 200 are popped. So it goes, again, n, p, x. Number total, probability of success, the number of successes that you want. We type that in our calculator here. So second distribution, go all the way down to binomial PDF, 250, comma 0.8, comma 200. Boom, boom, 0.063 we'll say. 0.063. Lo and behold, we're done. So that's about 6.3%. Okay. What about the probability that less than 220 will be popped? Okay, less than means I want below 220, right? I don't want 220 because 220 is not less than 220. I want 219 and under. So when you hear a less than or more than or at least or that kind of question, think what is the minimum you need? Less than 220. So what's the barrier number that I need? In this case, 219. 219 is the most I can have and be less than 220. So 219 and below. So I want the probability. Now, because I'm going below, I can just do CDF. There's no need to have a 1 minus here if you're going below, because once again, CDF by itself does from X on down. So I would type in this, 250 kernels total, 80% chance of being popped. The most I want is 219. That's the most amount of kernels I want popped. And then I want everything below that as well. That's where the CDF comes in. The C stands for cumulative. So 219 on down. I don't need to do 1 minus because the CDF already does on down naturally. The CDF goes below on its own. So second distribution, binomial CDF, 250, 0.8, 219, boom, 0.999. So 0.999. Okay? And again, that might seem like it's really high, but on average, we're going to expect to have, what, 200 kernels popped? So that's our average. So the chance that we get 220 kernels or less, that's a pretty high chance, right? Because on average, we're going to get 220 or 200. And so we're giving us a little bit more of a range here because we're starting at 219 essentially and then going down. So that it's a high probability, but it's not unreasonably high, okay? Because again, it makes logical sense in this case. Now, the more than one, the one that everybody hates, right? What's the probability that more than 230 kernels will be popped? Okay, so more than. So I have 230 here. I want more than 230. So what's the first number more than 230? Well, it's 231. So I want 231 and up. So if I'm going and up, that's my first clue. Okay, 1 minus binomial C, D, F, because I'm going up. So I know it's going to have to be 1 minus. 250, that's the same. 0.8, that's the same. The question becomes, well, what goes here? So let's think. 230 and up. Well, I can't go up. I can only go down. The calculator only goes down. So I need to get rid of the lower end. So I want to keep all these numbers, 230 and up, 231 and up, and I want to get rid of all these numbers, 230 and below. So I'm going to put a 230 in here because once again, that is at the end of a subtraction. So this is going to take away 230 and below. That's what minus BCDF does. It says take away everything from this number on down, which is what I want. If I put a 231 in here, I'd be getting rid of everything from 231 on down, which is not what I want. I want to keep the 231. If I put a 229 in there, I would get rid of 229, 228, and everything down there all the way down to 0. But I would still have the 230. But once again, ask yourself, is 230 more than 230? No, it's not. So I want to get rid of this. I have a number here I still need to get rid of. So I'm going to start at 230, go all the way down to 0, and then take all those probabilities out of the equation. So it looked like this. Boom, boom. So it'd be 1 minus binomial CDF, 250.8, and this would be 230. Boom. So very small amount. So 4.69 times 10 to the negative eighth. So 4.69 times 10 to the negative eighth. Or you can just jump this up 8 times if you want. No need to. You just write it just like this, and that's fine. Okay? And again, this makes logical sense. On average, we're going to have 220 kernels. I want to figure out what's the chance of us getting 231 or more. Well, that's already far above the average. 231 itself is already far above the average. And more above that is going to be even a smaller chance of getting it. So yes, this makes sense that this is a very high probability, just like it makes sense that this is a very low probability. Or, sorry, I said that backwards. It makes sense that this is a very low probability because, again, you want to get not only far above the average, but even more above that. It makes sense that this is a very high probability because you want to have a little bit above the average, so 220, and then you want to go down to hit the average 200, and then include all the probabilities down below that as well. So you're going down, here's 220, because remember, the average is the most likely outcome. Of all the probabilities, this is the most likely. So if I'm going 220 down below, I'm going to go 220 up to 200. That's my most likely outcome. And then everything all the way down to 0. So all these probabilities are going to be added up and get into here, which again makes sense why it's so high. I have the most likely outcome and everything below it and everything above it up to 220. Well, in this case here, I have 231 rather, and everything above it up to 250, because remember my maximum is 250. 250. Well, here is my most likely outcome, 200. That's my most likely outcome. I'm skipping my entire most likely outcome and starting way above it and then going up even more. So it makes sense that this is a very small probability because, once again, I want to beat my average and then beat it some more. Here, in this one, I want to go above my average but then go down, hit my average, my most likely outcome, and then go down even further just to add to my probabilities. So that's why there's a large discrepancy between these two values here. But again, less than CDF, more than 1 minus. And then the last one here is Poisson, right? Poisson if you're French. So, over the course of a school week, 5 days, a student cried because of their mean stats teacher 32 times. For some of you, it's a lowball number, but we'll say this is a pretty tough student here, so they only cry 32 times rather than what most of you probably do, or at least what I make most of you do. So, let's say we want to find the probability that a student cries 9 times a day. Okay, a day, that's the first clue, because I need to know the average per day if I want to do a probability for a day. Right now I know the average for a week, 32. So I'm going to take 32 cry days, or 32 cry times out of 5 days, right? Maybe they had a stats quiz coming up that they really weren't ready for. We're going to take 32 divided by 5, 6.4. So they cry on average 6.4 times a day because they're stats teacher, right? Probably the most they cry. So I want the probability that they cry 9 times in a day. Now, it is Poisson because it's over the course of a day or a unit of time, not a number of trials. So I would have Poisson, PDF, exact number of days, right? My average cry times a day is 6.4. I cry, well, I don't, but the student cries 6.4 times a day. I simply get angry. So 6.4 times a day. I want to check the likelihood that they're going to cry 9 times. So again, it goes the average you're using and the number you want to check against. So this tells the calculator, okay, this is your average. Check to see how likely it is that we get to here. So your calculator, you guys all know this by now, hopefully, because this is probably the more basic ones. Second vars, Poisson, 6.49, boom, 0.082. 0.082, or roughly 8.2%. Right? That's decently high, but not that much, right? Find the probability that the student cries 4 or fewer. Okay, 4 or fewer. Let's think here. 4 or fewer means I want 4 or less. Yes? So I want 4 all the way down to 0. Okay, so Poisson CDF of 6.4. Now, before I even go any further, do I need a 1 minus here? Well, no, because I'm going down. If I'm going down, if I'm going below a value, then I can just rely on CDF. I don't need to do the 1 minus. CDF naturally goes down. Think of the computer. Think of the calculator as a very negative machine. It will always go down naturally. You have to do a little bit extra work to make it go up. That's why you have to do the 1 minus when you're going more than. Now, what number goes here, right? The big question. 4 or fewer times in a day. All right. So I want to keep 4 because 4 does fit this description. 4 is 4 or fewer. So I want to keep 4 and go down. So I'm going to put a 4 here because that's the most I can cry in this situation. And then CDF will take care of everything below 4 as well. I don't want to put a 5 because that's too much. 5 is not 4 or fewer. I don't want to put a 3 because then I'm missing a value, in this case 4, because 4 is a valid number to use in this decision. 4 fits my description. If I said less than 4, then I would use a 3. But if I said 4 or fewer, I want to keep the 4. So I Poisson CDF. Let's go to our calculator here. So boom, Poisson CDF 6.4, comma 4, boom, boom, about 24%, right? So 0.235, 0.235, or roughly 23.5%. Again, not too low, not too high, about 1/4%, or 1/4 of a chance that they cry. 25% chance, roughly. So, what about the student cries 7 or more times a day? Okay, well, here's that or more thing. Now, this says 7 or more, so I want to include 7 and everything above it. So I want 7 and above. Now, again, I don't really have an ending number here because Poisson is continuous. It goes on forever. So I could theoretically cry 10,000, or not me, but you guys can theoretically cry 10,000, 20,000, 10 million times a day. Some of you might. So I don't have an upper limit here, but I just want 7 and above. So if I want 7 and above, that means I want to get rid of basically 6 and below. I want to get rid of all that junk. So I'm going to do 1 minus Poisson CDF of 6.4, comma, get rid of everything below 7. So 6, because I want to keep the 7 and get rid of everything below the 7. Now, technically, if you want to be really, really super accurate, you can do like 6.9, because that is, again, since we're doing fractional days, since we're doing an average, we can cry 6.9 times a day, theoretically speaking. So I could do that. But in general, I'm just doing whole numbers here, so we do a 6. That'd be perfectly fine. And so we would go 1 minus Poisson CDF of 6.4, comma 6. We get 0.458, we'll say, if we round. 0.458, or roughly 45.8%. So there's a pretty high chance that they're going to cry 7 or more times a day here. Again, that or more is the main thing there, because we can't go below 0, right? 4 down to 0, there's a limit there. 7, we can keep going up and up and up and up. Now it gets really, really unlikely that you cry more than 28 times in a day or so, but because we can keep going up and up and up ad infinitum, That's why this one is a lot higher than this one here, because there's really no upper limit on this one. Just to show you the difference, if you want to, like I said, be even more accurate, you can fractionalize this a little bit. So you can do 6.999999999. And again, it changes. Well, actually, this didn't change much at all because I did too many nines there. But if we do, actually, this is close to the average, so I might not bother with it. Boom, boom, boom. Yeah, see that didn't change at all either. Well, because we're so close to the average, it's not really moving the needle that much. But every now and then, if we were further away from the average, like the difference between 8 and 7.9 or stuff like that, that would change the value here slightly. But like I said, you don't necessarily need to worry about all the decimal finicky stuff here. Just think about this number in terms of whole numbers. So 7 or more means get rid of 6 or less. Don't think about 6.9 or 6.5. Just think about 6 or less and then keeping 7 or more. Same for here. 4 or less, get rid of 5 or more, so just count the 4 and less here with the normal CDF. And then finally, standard deviation. Now, again, in binomial, it was root NPQ, right? Well, for Poisson, we don't have an N, we don't have a P, we don't have a Q, so all we have is the average. So we would just simply square root 6.4, and that'd be our deviation. So whatever the square root of 6.4 is, 2.53. And there's our standard deviation. So if I wanted to figure out the maximum and minimum usual values, this plus 2 of these, this minus 2 of these, just like we did over here. The whole idea about plus or minus 2 deviations still holds in all three of these situations. So that's how you figure out the max and minimum usual values. Okay? Again, I hope this helped you out and hopefully alleviates some of you, or at least gives you some more examples to bounce your head around, and maybe, play this real quick during your study hall tomorrow to see if you can, make sure you cement that in one last time before the quiz. Like I said, this is not necessarily the only things you'll ever see on the quiz because, like I said, your quiz is longer than just, three things worth of this program here. But this does cover the main gist of it here. So if the study guide wasn't working for you and today's stuff didn't necessarily help you out, hopefully this will. Again, I'm here before and after school. Feel free to stop by. I'll give you as much help as I can. Don't stop by 2 minutes before school starts and expect me to be able to go through a whole bunch of stuff with you. So give me some time at least. But if you want to stop by before school tomorrow or during one of your study hall periods, I'm free this year at least. If you're watching it during the 2021 school year, I'm free third hour. I have a study hall, and then fifth hours, I'm free both fifth hours, and then, well, eighth hour, but the quiz will be over by then. So again, free by email too, so let me know. Hopefully this helped you out. I told you that I might give you a sneak peek at the stats quiz, so there you go. That's your sneak peek at the stats quiz. Hopefully you enjoyed that. But yeah, I'll see you all tomorrow, hopefully.